progress. All right, so this is homework problem number 13. And again, just a quick sketch of this. I have cables that are hanging, or a cable hanging between these two towers here. And it makes this U-type shape. And the name of that shape, by the way, is a catenary. Okay, 10 area. There we go. And it is modeled by a hyperbolic cosine function. So I'm going to put the y-axis in between there. This would be x equals negative 70 there. This is positive 70 there. And the towers up here are at 140.
Oh my, no way.
You okay?
Well, I was trying to do the plus symbol to write my answer in,
Yeah.
and I accidentally hit enter twice on 2 different occasions, so I had to get a new question, do all the work again.
Hey, when that happens, you got to slow down there. All right, so to set this up, let's see, length of the cable. Arc length is a version of the Pythagorean theorem tweaked a little bit. So it's the integral of the square root of 1 plus the derivative squared. So let's work our way up to that. F is given there, so f prime of x. The 25 out front hangs on because it's a constant multiple. Antiderivative for the cosh, just the hyperbolic sine, the sinh. Yeah, so I'm going to have a sinh of x over 25. And then since there's more than just an x inside, the chain rule jumps in and says, do what?
Do that. Take the derivative of x over 25.
Yeah, take the derivative of x over 25, which is just 1 over 25. And so our derivative is just the sinh, the hyperbolic sine of x over 25. All right, and then we're going to square that and add 1 to it. So before I get to the integral part, I want 1 plus f prime squared, which is going to give me 1 plus hyperbolic sine squared of x over 25. And let's consult our cheat sheet. Is that one of our formulas? It ought to be. Let's see. All right, so here we go. Hyperbolic cosine squared minus the hyperbolic sine squared is 1. So cosh is 1 plus the hyperbolic sine squared, cosh squared, excuse me, which is exactly what I have here. So this is the cosh squared of x over 25. And my integral says that it would really like the square root of all that, which is really nice for me. So back here for my integral, that simplifies down to just the integral of hyperbolic cosine of x over 25 dx negative 70, 70. Anybody notice if the hyperbolic cosine is an even function? Anybody remember what it means to be even? Even means if you plug in a negative x, it doesn't change the function. Right, so just side note, although that integral is fine, remember that the hyperbolic cosine is equal to e to the x plus e to the negative x over 2. And if we sneak inside a negative x instead, that gives me e to the negative x plus e to the x over 2. Is that really different than the original function? They're the same thing. So it turns out it is even. The nice thing about being an even function, that means it's symmetric about the y-axis. So instead of going from negative 70 to 70, I could just start at 0 and double the integral. Plugging in 0 is usually easier. All right, antiderivative for the hyperbolic cosine
The hyperbolic.
is the hyperbolic sine. So I'm going to get twice the hyperbolic sine or sinh of x over 25, but slight catch that x over 25 is a problem. If it was a derivative, I would multiply by the derivative of x over 25, which is 1 over 25. With the integral, I have to reverse that. What am I going to do? Divide by 1 over 25, which is multiplying by 25 in the end. You could use a u substitution to sort that out. Also,
That's because it's not a derivative.
yeah, when we take a derivative, we multiply by the derivative of the inside by the chain rule. In integral, you end up dividing by that constant instead. So instead of multiplying by 1 over 25 for a derivative, we divide by 1 over 25, which is a multiple of 25. How could I double check that's the right antiderivative? Take its derivative, see if you get back what was inside the integral, right? Which we should find we will. And I want to evaluate that from 0 to 70. And it asks for an exact answer, so I'm going to try to keep going without a calculator for a little bit. Eventually, I think I'm going to have to resort to a calculator.
Wait.
Yeah.
I'm so confused on why you crossed off the 70, but 0 on the
Okay.
two.
Because when I replace x with negative x here, I basically get the same function. These guys are equal. That means the function's even. And way back in the beginning of integration, we realized that if we integrate with symmetric boundaries an even function, then instead we can just double going from 0
Or whatever.
to the other side of that same function.
Okay.
If the function is even, which I just demonstrated this one was.
Oh yeah, that makes sense.
Yeah.
Yeah.
Because it's symmetric, even means symmetric about y.
It's like
Yeah, so instead of going from negative a to a, I can just double 0 to a. And the reason is usually plugging in 0 is easier. Not always, but usually. Okay, so then I'm going to pull out the constants. 2 times 25 is a 50. And then I'm going to get the sinh of 70 over 25, which is probably not a nice number, minus the sinh of 0. Sinh of 0, that one, let's see. Sinh of 0, just for fun, that would be e to the 0 minus e to the negative 0 over 2. What's e to the 0? 1. E to the negative 0 is still 1. 1 minus 1 is 0. So it turns out the sinh of 0, like the sine of 0, is 0. It passes through the origin. All right, so that means that one's gone. So my exact answer is that right there. Okay, what? That was a lot of work. What could I do to double check this?
Plug it in, like the original integral and the Desmos.
Yeah, plug the original integral into Desmos. So what I would do to double check this, and I'm going to in a second, is I'm just going to go to that as the integral, and I'm going to plug into that my function and do a numeric integral and see if it matches what I think the exact answer is. Let's do it. All right. Reload Desmos here. All right, so I'm going to say f of x equals 25 times, and you can just type in Desmos COSH x over 25. And I'm going to adjust the window to see that. All right, so let's see, my x needs to go up a bit higher. How tall are my towers? 140? So let's, oh, I would go left and right. Oh yeah, 70, negative 70. So let's go up to 100 on each side. And for y, that's where we need to go up higher. Go up to 200. enough. And again, I'm going from x equals -70 to x equals 70. Just want to get a peek at what I'm doing. Oops. That doesn't seem to match the problem. -70, 70. Oh, the towers are 140 meters apart. Sorry, I thought I read it was 140 meters tall when I drew my sketch. So I misread the 140. All
But
right,
that's still the same as the interval.
what's that?
That's just the interval.
That's just the interval we're doing. Yeah, I misread that. All right. So again, I think my answer is 50 times the sinh. Oop, it's SINH. We'll put a C in there of 70 over 25. So I think that should be the arc length. I'm going to check with the integral. Let's see. I think I'm going to just enter an f prime. So let's call f prime a. And it is going to be the 25's cancel. That's just the sinh, right? SINH of x over 25. See that? And so now, and again, I didn't have to do this, but I'm going to.
Yeah.
I want to go twice the integral. Actually, no, I want to do the original one. Make sure I get it right. -70 to 70. Then I want the square root 1 plus parentheses squared, and I'm just going to plug in what I typed. So you could either type SINH of x over 25, or if you enter it as a function, you could just enter your function. Oops.
The x is
Yeah, thank you. And they should
Bang.
match. Bang. Got it. Okay.
So when we made it exactly,